he's based in Singapore, and with over 20 years of experience in mechanical engineering and CAD industries, he has been involved in mechanical design, simulation, as well as project management. His primary role involved working closely with partner teams in the ecosystem to help businesses on their digitalization journey. So for today, Sean will be sharing with us a case study of how the solid edge software can help a company in its digitalization process. So hand over to Sean now. Thanks.
Thanks, Lynn. Hi, good afternoon to everybody, and glad that you could join us. For those of you who have been with us for the last webinar, we went through a little bit of an introduction into digitalization and how that can help your processes. So today we want to actually go a bit more in depth into this entire idea, and I'll just share with you an example of one of our customers who has actually benefited from the digital transformation of their company. So first, a little recap for those of you who may not have been with us at our last webinar. What is digitalization and how does it help? Well, study by IDC, the International Data Corporation, they did a study of companies that actually looked into implementing the digital twin technology. And what they found was that companies who actually invest in the digital twin technology or digitalization, on the whole, see about a 30% improvement in the cycle times of their critical processes. And that's a lot. And what are these critical processes? As you can see from the slide, they go from concept design to detailed design, simulation, manufacture, installation, service, and all this is managed throughout the entire cycle, managing the entire data as well. So it's all these processes that come together and are critical to what a company like yourself would need to do and would benefit from. And so what we want to do is to help you on that journey. Right. So for small and medium businesses, we've got, as you can see here, a list of about 7 pillars that we call our pillars of digitalization, from mechanical design to electrical design. These two are very important today, to simulation, which is actually validating your design before you commit to doing things like prototyping. Manufacturing, obviously, every part needs to be manufactured. Then technical publications is something that many people don't pay attention to, but are essential in terms of communicating the data to the people who are assembling your machines or your products, to even things like maintenance. Again, all of this data needs to be managed properly, from file naming to revision control to security. All these things are handled under data management, and many companies can actually benefit from this data management. And finally, collaboration with people outside your company, your suppliers, your customers, finding ways of having a very interactive communication and collaboration so you can share ideas much faster and lower your cycle times further. So we're going to look into this customer of ours called Mecmesin. So let's have a look at the video.
Manufacturer of force, torque and materials testing instruments and systems. We began our existence about 42 years ago, 1977, and since then we've grown into a truly global organization with more than 130 employees around the world. We're very proud to say that we've managed to keep all of our product design, mechanical, electronic and software design in-house, and we consider Solid Edge a very vital part of that team. Mecmesin's grown year on year consistently, but this year we're planning a step change by building a reputation in the materials testing application space. To do this, we've just released a whole range of products called OmniTest with cutting-edge Vector Pro software and a whole range of accessories aimed specifically at that market. Digitalization is, I believe, a natural evolution of most modern businesses. SME manufacturing may not seem very modern or progressive to most people, but without digitalization, I don't think we'd really be where we are today.
Solid Edge is a great collaboration tool. It enables us to provide concept designs to our sales engineers, who are then able to discuss these designs with customers and then feed back any design changes, modifications, and then we can make these changes quickly and then proceed to the next stage of the design process. Solid Edge helps us provide an accurate visualization of the product, and with the design tools available, we can have a high confidence of success before we commit to a prototype.
Solid Edge can really help us with integrating electronic design, reduction of the use of physical prototyping, and even simulating testing scenarios.
Generative design capabilities in Solid Edge have helped us create new, more cost-effective solutions for some existing components, with cost savings up to 300%. We are using generative design to help with the integration of 3D printed parts to replace traditionally machined parts in our production lines. With the new augmented reality tool within Solid Edge, it will enable our sales engineers to provide perfect visualizations for the customers. This will enable us to show digital designs in a physical environment. The contrast between our company pre-Solid Edge is that we have now been able to develop our product from heavy industrial-like boxes to lightweight ergonomic designs, which are structurally strong and robust.
What I'd like to see for the future of Mecmesin is to be considered in the same breath as some of the leaders in the materials testing space, while retaining our reputation as in the QA application space, as well as force gauges and torque testing. And Solid Edge is a vital part of this.
Yeah, so you can see Mecmesin is, they make machines for torque testing, and the machine that we're going to take a closer look at in some of our examples. What they do is that these machines actually test the torque of bottle caps. Once the cap is screwed on, they want to test whether it's tight enough. So they're based in UK, and so they design and manufacture electromechanical force and torque testing systems. So what has happened is that over the past years, they've actually grown. So now they have about 180 employees, which is still considered small and medium businesses, but they've grown considerably since they've adopted these digital transformation tools. And they have a reputation for quality, reliability, and customer service that they would like to keep, right? And what are the challenges that actually drove them to adopt these digitalization tools? So first of all, reducing time to market while maintaining product quality. I think that's something that everyone can identify with. Optimization to save material costs is also very important. Validation to reduce costly prototypes, not just the cost of building the prototypes, but also the time taken to build the prototypes. It's something that needs to be considered. And a big one is collaboration between mechanical and electrical departments. And this is something that I'm sure any company with both an electrical and mechanical department will understand that the collaboration usually isn't quite there as much as we want to, right? Also, a seamless design to manufacturing integration is also very useful. And like I mentioned just now, creating high quality technical documentation, right? And maintaining that digital twin, right? So the digital twin basically is a twin of the real world parts. But before you even commit to the manufacture, the tooling cost of creating these real world parts. So what you're doing is you're optimizing the twin so that when you actually manufacture the parts, it is right the first time. That's what you hope for it, all right? And at the same time, we're looking at linking and tracing customer requirements and the specifications with the CAD data, and all the while collaboration with partners and suppliers, right? So I'm going to go through a few of these processes that Mecmesin has adopted. One of them is generative design. Now, generative design is a fairly new technology. Some of you may know it as topology optimization. So basically, in traditional design sense, what we do is we design a shape, okay, using our experience, engineering practices, and your traditional CAD software. You build a shape, and then what you do after that is you then validate it. You validate it either physically, or maybe you do simulation in your software to test whether it meets your requirements or not, right? But we can see that this is a very sequential kind of method and process, right? So if you need to make a change, then you have to go back and manually change everything and then go and test it again, right? So what generative design does is actually it shortcuts this a cycle, right? Because it is an iterative process. So with generative design, you use the software and the computing power to create a shape, and the validation is an integral part of the design process. So here's an example, right? In this Mecmesin machine, we have this part here that's used to test the top, that sits on top of the bottle cap. We want to be able to reduce the weight, reduce the mass, so we use generative design. As you can see, by putting in the boundary conditions, by putting in all the sets of criteria, we're able to reduce the mass, and it will run through that cycle very quickly without us having to input. And by changing manufacturing settings, you can actually make a very, very complex part, or you can make something like this, a little bit more manufacturable using your traditional machining processes. So these are all options that are available to you in generative design, where you can either specify a safety factor, or you can specify a reduction of weight by X%, right? And as you can see, all the areas of high stress are available to you, so you can see exactly what are the areas you need to concentrate on, which is very, very useful. Now, usually this kind of thing, the resulting shape is what we call a mesh part, right, which doesn't sit well with CAD data. But in Solid Edge, by using our convergent technology, we're able to place this mesh data without converting it into our regular CAD environment, and do things like add holes, add other normal CAD features, and we can place it very well into it. Okay, so as a summary of generative design, what you're doing is you're minimizing the component weight while still retaining the strength that you require for the part itself. Okay, so you can reduce the weight of critical components to improve the overall efficiency, reduce energy consumption, because if this part is connected, it needs to move up and down. So you have to take into account the motor and the power of the motor required to move this part up and down. If you reduce the mass of the part, it also means that you can reduce the size and power of the motor, which means that your other costs will go down as well. So it's a very good downstream kind of virtuous cycle. And of course, the other thing is to meet regulatory requirements. And you're reducing component costs by reducing the material volume as well as the material cost. Now, here's another example, reverse engineering. Now, reverse engineering has been with us for some time now, right? So basically with reverse engineering, you can convert an existing physical part to a virtual 3D model, and then you're able to alter it to improve the design. So what this does is that it results in faster time to market for new parts. Also, as well, a continuous quality improvement and customization of existing models and parts that you may not have a 3D CAD model for. And it also cuts down production costs. Now, how does Mecmesin use reverse engineering? So what they might do is that they might need to cater for different sizes of bottles, right, to build an insert for these bottles. But the bottles, they don't have the CAD model themselves. So what they do is they scan this in, and they just obtain the bottom part of the bottle, right? You can get rid of areas that you don't want, like, this imprints of dates and stuff like that, and very quickly fill in that mesh. Now, this is the great part. Using convergent modeling, you're able to then take this mesh data and take away what the bottom of the bottle looks like, put it into a normal CAD model, create your insert, and just like a normal CAD part, you can place it in, and there you go. So there is the insert of the bottle very easily, and you can create different inserts for different size bottles. So this is just one application that you can use for reverse engineering, right? Very, very powerful there. So with reverse engineering, you can reuse designs without any CAD data at all. You don't have to build them up from scratch like you normally might have to. If there are any faults in the mesh, you can automatically automate the repair of them. You can smoothen out and stitch imperfections, and you can incorporate all this data into the CAD models themselves. So you can see this collaboration between the physical data that you might have as well as your CAD model. Now, all this will then result in parts that you may want to say, okay, I've got various ways of manufacturing, right? Of course, you have your traditional CNC machines, which is one of the most common ways of manufacturing. But increasingly, we're hearing more about additive manufacturing. Now, you might think additive manufacturing is not relevant to you, right? But I ask you to reconsider this. Now, we know that the process of additive manufacturing is comparatively much faster than traditional manufacturing, right? Because there isn't all this, preparation of the tools, tool path, to go through and then to do a test cut and all of that, right? So it allows ideas and iterations to be tested very, very quickly if you do additive manufacturing or 3D printing, as we very commonly know right now. It's also ideal for things like prototyping, where you need to do like test fits, right? It can be used in conjunction with traditional manufacturing rather than like an either-or kind of situation. Now, many 3D printers are much cheaper and smaller than CNC machines. Of course, CNC machines, you require dedicated space, dedicated loading, floor loading, so for your office and all that. But 3D printers can be very small. The modern 3D printers can sit even on your desks, so it can fit easily in your home or your office. So that's another consideration to have. And a very important one is that you do not need special training to operate a 3D printer, whereas obviously with a CNC machine, there's a lot of training to go through. Not anyone can use it. A big one is cost. The cost of 3D printers these days has come down dramatically. So even for something that's fairly advanced, it can be you can obtain something at a very reasonable cost. There's no tooling required. It's perfect for things like low volume, highly customized production, and you can build complex geometry with ease. So why 3D printing has become more and more popular is because of these reasons, because obviously the cost has come down, the space is much less, and the training is obviously not so much required, right? So here's an example. This part used to be a top plate of the Mecmesin machine, and used to be made of metal, which is very heavy, right? But as we know, you don't need this top plate to be so heavy and made of metal. So as you can see, in Solid Edge, you have a 3D print area directly, okay? So with this, you can then output it and send it directly to the 3D printer if you have one. Now, what if you do not have a 3D printer? As you can see, there is an order online button. So this order online button is really very special. You click on it, and it's something like Amazon, right, for your designs, right? So you click on it, and it analyzes your part, and then what happens is that it then sends all this information to our online vendors. So depending on the material, depending on the processes that you want, you can see all your choices over here and the cost. And then you can say, okay, I select this vendor based on the cost, based on the process, and you select the color and click continue, pay with your credit card, and in X number of days you'll find it at your doorstep. So this is really a game changer, because not only are you able to utilize the 3D printing technology, but you're able to either you're even able to utilize it without having a printer with you. So in summary, with additive manufacturing, you can build parts faster and cheaper with more flexibility than you would otherwise with traditional machining techniques, and you can output directly to a 3D printer or utilize the online services. Now, a very important one, like I mentioned before, is increasing electromechanical integration, right? Because if the products that we have around us, many of them are no longer just mechanical products. Even things like our office desks, many of them now can move up and down, you know. So they use some form of motor, some form of electronics. And a challenge, a big challenge of many companies that have both mechanical and electronic or electrical CAD teams is the collaboration or lack of collaboration. So one of the reports and surveys done has shown these are the top problems facing ECAD and MCAD departments, right? Number one, poor communication. 79% said there is poor communication and a silo mentality. And this results in lost time, right? Because there's extra communication required or a lack of understanding between departments. 72% said that the respective tools are not compatible at all. So that breaks the workflow. And so they say that increased ECAD and MCAD integration would reduce development time. And 70% say that design changes, testing, and prototyping all increase the need for frequent meetings and rework. So what if we could cut down this meetings? Why? Because if you have an integrated set of integrated tools, this would save the time. So what we have in Solid Edge is a Solid Edge electrical set of modules. Now, this really integrates well. The first step, of course, is to create your electrical schematic, right? So as you can see, this is a schematic here that's done. Now, the lines are not, dumb lines that mean nothing. Each line, each wire, each component has properties. You can drag and drop it from from the library, and it all has properties that will pass downstream. There's also a validation tool, as you can see over here, that is able to test whether your circuit works the way you want it. The important thing is this part, the integration. You see your mechanical on the left and your electrical on the right. So what happens is that this electrical circuit that you design, you can use the Solid Edge Connect and bridge out all the data to the mechanical so that the mechanical guys don't have to redo all the wiring data all over again. All the data is there. All they need to do is route the wires physically, which is their job, and then what happens is that it automatically updates both sides. And finally, you're able to create the form board. Now, what the form board does is that it lays out everything. It automatically provides you a parts list of your component table and your conductor table. And it really helps both the procurement department to know exactly what parts to buy, as well as the guy who is finally doing the physical connecting of the wires, which wires go into which connector, which pin, so on and so forth. So as you can see, this integration between the electrical and mechanical actually helps the entire process to shorten, and it improves the communication. So number one, you have intuitive electrical circuit design. The built-in libraries means that you can actually reuse your data a lot faster. There's a simulation and validation that highlights any errors that you might have. There's a graphical layout of the harness and form board designs. And finally, and probably most importantly, the tight integration between ECAD and MCAD teams. So as a result of just some of these tools that I have shown you, Mecmesin, these are the benefits that Mecmesin has been able to reap. So firstly, it facilitates the engineers to seamlessly transition between 2D and 3D and rendering. There's a significant cost savings and 70% reduction of design time using both generative and reverse engineering. A 50% reduction in design turnaround time. Wiring and harness and also PCB design ensures good MCAD and ECAD integration, reduce project management time and costs with requirements traceability. And lastly, making use of 3D printing, they've actually really taken advantage of that. So about 40% of their parts are 3D printed. So as a result of this IDC survey, okay, they surveyed small and medium businesses to find out where do small and medium businesses stand right now. And these were their findings, right? 90% of small and medium businesses already have a budget in place for digital transformation. 50%, they agree that digital transformation are innovation accelerators. 50% also are already dedicating staff to support digitalization, and over 30% have begun their digital transformation journey. This is what other companies are doing. This is what your competitors are doing. So this is the last message that I leave you with. Where can digitalization take you? So with that, I thank you for your time.